through 5 graphing linear equalities. Today's terminology is inequality. An inequality is a mathematical sentence or statement using comparing symbols such as your less than, greater than, less than or equal to, and greater than or equal to signs. When graphing linear equalities, there's 3 steps that you'll want to refer to. Make sure step 1 is it's in slope intercept form. Step 2 is a big one. Make sure that anytime that is a less than or equal to or greater than or to equal sign, that you are using a solid boundary line. And when it is less than or greater than, it is a dotted or dashed boundary line. The dashed boundary line means that the values are not included. The solid boundary lines means the value is included. And then step 3 is basically to determine which area or region that you need to shade. You can do this by looking at the signs, or you can do this by doing a testing point. The majority of the examples I'll show you by looking at a testing point. So our first example here, we are going to graph the inequality y is less than or equal to 1/2 x minus 3. I'm going to go ahead and just fill in a few things right here, like my intercept and my slope. So here is my slope. My slope on this problem, m equals 1/2, and my intercept is -3. I'm going to use my slope-intercept form of graphing. So here is -3, and then my slope is 1/2. So rise is 1, the run is 2. Plot, and then I can go ahead and construct my boundary line. Now my boundary line here, remember, you take into consideration what you're signing. It is a less than or equal to sign. So looking at the instructions in step 2, when it is less than or equal to, it will be a solid boundary line. After you have constructed your line, your next step would be step 3, and that's determine which area or region that you need to shade. What I like to do is, if my line does not go through my origin, use this as a testing point. So your origin is 0.00. So what you will do is plug that back into your original equation up here. So if it's 0, 0, your y value is 0. Y is less than or equal to. You have 1/2 times 0 for x, which is going to give you 0, minus 3. So you have 0 is less than or equal to -3. The next thing that you need to determine, is this a true statement? Is 0 less than or equal to -3? And that is not true. So this point here is not a true statement. This point is above the line, so I need to shade everything below the line. Reason being is because all these points would make this a true solution. Remember, 0, 0 did not work, and that was above the line, so all the ones below the line would work. Another thing that you can reference is in step 2, or actually in step 3, is check out this. Less than or equal to. Less than or equal to, you fill in below the boundary line. Again, our next example, y is greater than x. I'm going to go ahead and fill in my slope. My slope is next to x. I can always put a 1 there, so my slope is 1. My intercept would be 0. Slope-intercept form of graphing. My intercept is 0. My slope is 1, really 1 over 1. So your rise is 1 and your run is 1. I'm going to plot that. Next thing that I'd want to reference is the sign. This is a greater than sign. Greater than sign requires a dotted line. So using these 2 points, I'm going to construct a dotted line. Remember, a dotted line means that these values that lie on that linear line are not included. Next, I would go ahead and use a point to test. A point to test would be any line that is not on that line. So I'm going to go ahead and use, I'll use this point right here. That point would be your x value is 0, your y value is 3. So x value is 0. your y value is 3, and I have 3 is greater than 0. Is that a true statement? Yes, it is. So if it's a true statement, all these values up here are true, and that would shade up the top above the line. Notice I did not use my origin 0, 0 because I go through the origin, so you would not want to use that point.